level at flight level 370. There's a glimpse of the flight deck that we're looking at right now, and everything's normal. Let's go and have a quick look at what the QRH actually says. It's a pretty lengthy checklist. So for the purpose of teaching and briefing, I've broken it down into 4 different segments, all color-coded with degrees of severity. There are other scenarios in this checklist, but these are probably 4 of the most critical. Let's cover one scenario first. We'll go through the QRH, and we will then go into the airplane, and we'll try to duplicate as much of it as we can. So loss of thrust on both engines could be caused by contaminated fuel, could be caused by heavy water ingestion as you're circumnavigating thunderstorms. It could be caused by volcanic ash. However, that is covered in a different QRH procedure. So let's just talk about loss of thrust on both engines. The condition both of these occur, both engines have a loss of thrust, and both engine fail lights show. And of course, the objective is to restart at least one engine. As in any flight, you fly the airplane first. And if you notice, there are 4 recall items. You're going to have to do these items fairly quickly, but at the same time, you're going to have to fly the airplane. Now, you're going to find out later when we go into the airplane and that the first officer has no flight instruments. When you lose 2 engines, you've lost both generators, and only the captain has flight instruments off of the hot battery bus powered for only 30 minutes if you have a single battery. And so these are big considerations that we're going to be talking about today. So immediately the captain would take control and fly the airplane. And it's going to be manual flight. There's no autopilot, there's no auto throttles, and there's no electric trim. Which means he's going to quickly have to use the manual trim wheel. And before he does that, and it's not in the checklist, he really should ask the first officer to move the stab trim cutout switches to cutout. Why? This is as a protection for later when you do restore electrical power, either through the APU or getting one or both engines started and following the checklist. You may very easily forget that you've got the trim handles out. And when you restore power and you restore electric trim, you could really hurt yourself. So this is a suggestion. It's called airmanship. So pilot flying, fly the airplane. Pilot flying has got to go for an airspeed. And that airspeed is 275 knots if you're above flight level 270. And we are. We're at flight level 370. If below flight level 270, the speed is 300 knots. High speed, all intentionally high speed to keep the engines windmilling. Unless they both seize, highly unlikely that you've have 2 seizures. So we're talking about windmilling engines, and with airspeed, altitude loss, of course, but with high airspeed, you'll have windmilling engines, and the probabilities that you'll be able to get a windmill relight are high. All right, so we'll say the captain's flying, he flies the airplane, keeping those things in mind. First officer, engine start switches both flight. Engine start levers both cut off. When the EGT starts decreasing, then move the start levers, both of them, to the idle dead end. If EGT reaches a red line or there is no increase in EGT within 30 seconds, that's one or the other, the engine start lever for the affected engine confirm cutoff. And then idle dedent and repeat the sequence of the same procedure. And if EGT again reaches the red line or there is no increase in EGT in 30 seconds, repeat as needed. Those are memory items. And the first officer will be doing those items because the captain has to fly the airplane. So that is the scenario. I've got this here. We just talked about it. And the reason why I've highlighted it is because it's important. While the pilot, while the first officer is doing these items and focusing on trying to get an engine relit, the captain is flying the airplane with judicial use of the VHF. Because without generators powering the buses, the battery is only good for 30 minutes if it's a single battery, and 60 minutes if you have two batteries. Every time you touch a VHF switch, you are draining that battery. By exactly how much, I don't have figures. Boeing haven't put out any figures. But you want to make sure that you don't talk too much on number one VHF, say the right thing and say enough. Of course, this is a Mayday. So be careful how long you are transmitting. Likewise, when you go to start the APU, we'll talk about that shortly, remember that each attempt takes 6 minutes from your battery. So if you don't get a light immediately at high altitude, wait until you get to lower altitudes. And as you know from the engine in-flight relight and engine after an engine shutdown, that you probably won't get the APU started when you're drifting down until you're close to flight level 260. That's in the QRH. You want to have all that salted away, but you certainly want to try the APU as quickly as you can. And if you actually see down here number 7, do not wait for a successful engine start before starting the APU. So the first officer, it will do all of these memory items and try to get the engine started and repeat and repeat and repeat. But this little item here is very important and could have been up here somewhere, just below the memorized items, only because it's important. So you certainly want to get electrics back so that you can get electric trim, and and you want to get your engines back. So remember that the objective is to restart the engines, at least one engine. I'm going to continue on now reading this first scenario in this first video. So let's say choose one that the APU was available for start, that you did dispatch with an operable APU. So you try to start the APU and go to step 9. When the APU is running, APU gen switches on one at a time. And remember, we do everything left to right. All right. Then number 10, one or both engines start. Let's say that's the scenario. Or let's just say both engines start. Go to step 15. When engine parameters have stabilized, engine start switch as needed. Remember, the first officer put the engine start switches, both of them, that was his first action, to flight before he moved the engine start levers to cutoff. So engine start switches as required. So that's in step 15. And thrust lever for the no, I would leave them in continuous, definitely. At least you've got one igniter in continuous working. And why did the engines flame out? Was it contaminated fuel? So you certainly want to protect the engine. And are you still circumnavigating thunderstorms and you're in heavy, heavy, heavy rain, which could have caused the engine loss of thrust. So you've got to use your head. So thrust lever for the operating engine advance slowly. Generator switch on the operating engine on. Go to step 25. Now remember, the first officer is doing this. The captain is doing one thing, flying the airplane safely and communicating only when required until you get electrics back on the AC transfer buses. Here's one. Both the captain and first officer's primary attitude displays are operative. We will say that is the case. And attitude flags are not shown. Go to step 30. Meanwhile, in this procedure, the first officer will be very busy focusing on the checklist. And it's very easy to get confused because there are many scenarios here. So this scenario, both engines are running, run the APU as needed, and end of checklist. So if you got two engines back, I would certainly keep the APU running in case you had whatever the problem was that you didn't know. Maybe it was contaminated fuel that caused both engines to flame out. You don't know, or loss of thrust. So that is one scenario, and I kind of highlighted everything in green because it's probably the best scenario. You got your engines back, and you got the APU going. On the next scenario, it'll be a little more critical. But before we do that, let's go right into the aircraft and have a look at a good airplane, everything running fine, and then you had this happen. If you notice, the first officer has lost everything. Captain says, I have control, takes control and flies the airplane. The autopilot's disengaged, the autothrottle's disengaged, and you're descending. You have many things that have happened, and master caution is on. You've got problems with the fuel and electrics. Let's go up and have a look and see. You have got a lot of lights on in a lot of systems, and just going around the flight deck, let's just have a look. You've got an auto slat fail. The yaw damper has actually kicked off. And remember that the standby hydraulic system needs electrical power to operate, and you don't have electrical power. You've only got electrical power on the airplane to feed essential items. Are some the lights you're seeing obviously come from the battery, but the captain's flight instruments are powered by the battery, enough for him to fly the airplane for 30 minutes with judicial use of the VHF and any high drawing devices, such as starting the APU. It sucks 6 minutes off of your battery. So you've got to remember that. And of course, your generator drive lights are on, your transfer bus off lights are on, source off lights are on, all the fuel boost pump lights are on. These are all powered from your AC transfer buses and associated attached main AC buses and DC buses. So going around the flight deck again, you and as far as your cabin pressurization is concerned, your packs are off. You're in a manual mode for pressurization, and that manual mode is coming from the battery. Remember that. And now when you look at the hydraulics, you have lost the electrical hydraulic pump, hydraulic pump number 2 and hydraulic pump system number 1. However, if you notice, the engines are windmilling, and you do have hydraulic pressure. So you haven't lost hydraulics. Let's go down and have a look at that. Now, there are your engine fail lights, as we saw in the QRH. And if you notice, you do have N1 close to 21%, and you do have N2 at 28%. And at this present time, we're at flight level 355, and the airspeed is 244 knots. So the captain is going to certainly have to pitch down and get the airspeed up. Remember, the airspeed above flight level 270 should be 275 knots. So, and the reason, one of the reasons for that is to get a high enough windmilling RPM so that you can get a windmill start as we're reading through the checklist. So that's very important. Okay, so let's just pause for a second. My suggestion is the captain is going to have to trim the airplane, and it's going to be a manual trim. Before he does, he should ask the first officer, call on the first officer to actually move the stab trim switches to cutout, because that's a protection. It's not written in the manual. This is common sense, because you're going to go over and use the manual trim wheel. And as I mentioned before, you don't want the manual trim wheel handle out when you reinstate electrical power later. You're going to tear off somebody's leg. Maybe it's yours or your first officer's or whatever, and you're going to hurt yourself. So you've got to think out of the box. So make sure they're moved to cut off. And then when you do reinstate electrical power, either through the APU and or through one engine or both engines, then at least you're safe until you have the trim handle stowed before reinstating electrical power by moving the stab trim cutout back to normal. So think about that. Now just have a look at your rate of descent also. Now your speed is increasing, and as it's increasing, we should actually be getting more N2 and N1. Let's go across and have a look at that. Yes, we're at 29.2. So N2, of course, is increasing, and it will get higher. And that's what you want, because as we go down through the checklist, we're going to be looking at hopefully getting a windmilling start. So we'll finish the scenario 1 here. That's probably a good time. And then we'll go into a part 2 of scenario 1 of the next video. Thanks for watching.